Hi, welcome. This is take 2 of day 13 of Just Start Programming. Creating console terminal apps using Rust and Ratatui. So last time when I started streaming, I think I was encountering some network issues. So I have to restart it once again. So today, hopefully, my network is okay. Yeah. And let's continue with application recipes. Config directories, logging with tracing, terminal and event handler, and let's see how much we can cover today. So join me once again live in one take, no shortcuts and no secrets. So let's just start programming. All right, so here we are once again. So last time we were trying out directories. Using directories RS for path resolution. So we have cargo add directories, and here cargo.toml file we have directories version 6. And we copy the code. However, there's not much explanation here. So what we can do is over here, I was searching for the directories crate. So directories version 6. So let's take a look at the documentation. So it provides a platform-specific user-accessible locations for finding and storing configuration, cache, and other data. So it supports Linux, Redux, and Windows, and macOS. XDG base directory and XDG user directory specifications on Linux. What is this? Data home, config home, state home. Data home defines the base directory. Okay. So that's XDG. And here, what do we have? Project DIRs computes the location of cache, config, or data directories for a specific application, which are derived from standard directories and the name of the project organization. So you have base, project, and user directory. Let's inspect the code. I think from the sample code, it was project DIRs. Okay, so let's see what's going on here. From Rust standard library, we have process environment. Then we have the variable, environment variable key. Okay, so if key equals to home, let's do this step by step. Let's try this one first. Okay, so we don't have to do this. Okay, if key equals to home, bar key, print line key, and val couldn't interpret. Start this. I think there's a compilation error. Failed to resolve. Linked. Unresolved module or link rate env. Use std env. Okay, it's there. Okay, so why do we have cargo run dash dash name Joe dash d hello hello? I think this was from the previous example that we did using arguments. Yeah, here. Description. Name, count, and description. Okay, so home, it displayed something, so it went here. Home, just start programming. So that's my home directory. Why did we have that? Okay, so I think because I was looking into env here. Okay, we got that example here. Okay, Ratatui template data. So if we change it into Ratatui template data, let's see what shows up. Couldn't interpret Ratatouille template data. Environment variable not found. Okay, so we cannot use this. Directory. Path buff from S. Okay, so instead of Ratatouille template data, maybe we can set something else. How do we do that? Set export. My template or my project data. My project data equals let's use our path here. Projects Rust series 2 CLI arguments. Then env, or no, not env, echo my project data. Okay. And then we use this one, my project data, in the code. Let's not use this. Oops. My project data. Project data. Okay. And let's run that. There. My project data. So it's correct. Because in the environment variable, we have that value. Okay. Okay, so this one, if what does it do here? Path buff from S directory, else some project dir. Let's take this apart one by one. Maybe copy this part. Not from there. Here. It is missing. Okay, semicolon. Semicolon. We'll change the key. My project data. So what's the issue now? If let okay, this one, so the string will be here, string S directory is the return of path buff. So if is missing else clause. Maybe let's use this one. Unable to find data directory. Okay, maybe not Ratatui template, but let's put my project data. Expected because of the default return type. I don't want to return anything. We're not inside a function. If and else have incompatible types. Error E. Path buff. Okay, let's simplify this further. If okay, then this one will return path buff. Else, this one should return path buff. Okay, so let's remove this. Path buff. Let's create a new one. From S is string. Should put here. I don't know, maybe test. If that will work. I don't have test here. New folder, test. Or maybe not slash test, but test. Okay, so that is directory quick fix. Oh, then let's use directory. Debug macro, maybe directory. Did it show us anything? Okay, probably yes. Probably we'll see some values. Okay, let's run this one. Yeah, I'll just keep that one. I'll keep this. Okay, so it shows directory is equals to home, just start programming projects, Rust series 2 CLI arguments. Yeah, so that's the value of this one. What if we change and make it something unrecognizable? Maybe, let's say, project data. So project data doesn't have any value, so it will jump to else, and maybe it will return test. Let's find out. There. Okay, so that's the simplest example I can think of. But we haven't used project dir from. Okay, so let's try this one and see how it looks. I think it's there in the code also. Copy. Let's put it here. Modifier com. Okay, let's retain the author of this example. Let's see how it looks. Show up. It showed something else. That config Ratatui template. Oh, .config Ratatui template. Let's see. I think we have that as well somewhere. Config, yeah, Ratatui. Oh, we only have config. There's no Ratatouille template. Under config. Okay. So why did it return .config? Is it because of this? Project dir's config local dir to path buffer. Local dir. Okay. So in project dirs, you can easily get the config location. So that is .config. So home.config. So I'm using Linux. Let's check the documentation here. Project dirs. Okay, so config dir. Okay, config local dir. If it's config dir, you'll have home.config. So in Windows, it will look like this. Windows is using updata. Mac OS is using library. Okay, but here, what does com, full corp, and bar app represent? In Linux, it will appear as bar app. Bar app. Why bar app? While in Windows, it will appear as full corp. Okay, full corp is here. Where is com? Com is not here. Bar app. While in Mac OS, you have com full corp bar. Wait a minute. So we are in Linux. So it took bar app from this one. So it's doing some kind of translation that is compatible to the operating system. It seems. So maybe that's why we only see Ratatouille. Ratatouille template. So this one was displayed. Run it again. Yes. So there, Ratatouille template. But say if we put space here, will it remove the space and join these two words together? just like this one, bar app. Let's make it uppercase also. Ratatui template. Correct. So this is in Linux. It's the behavior. It's the behavior. So if you look at the code, the first one is qualifier, second one is organization, third one is application. So application is the application name. So probably, yeah, so bar app. So in Windows, it will be the bar app. Food Corp. So in Windows, that's the org. And everything goes into app data roaming. Okay, understand. So what else is here? This is data, and then this is config. Okay, so config we tried. So data, maybe we can just take a look from the documentation. Project path, config, data dir. So in Linux, it will be translated as something like this. Example, you have dot local, share, bar app. Do I have dot local here? Dot local, I have. Okay, so that's in Linux. Yeah, so that's how it works. So you can, using this library directories, then you can easily get XDG based directory specification. So it will be I think it will be according to which OS you are in. Alright, so that's good to know. It's also useful in the future. We have some standard configuration files stored in the .config, so we can easily read that one. Maybe .config SSH, or SSH is in .config. Remember, let's see. Linux SSH config file location. Oh, this one is different. It's .ssh, then you have config. So probably that one we don't have. Okay. So there are other methods. Cache directory. Okay, so there will be linux.cache. Config local, we have tried. Config projects config directory. Projects local config directory. Data from is what? Creates a project near struct from the values describing the project. from path. Preference. Okay, so almost the same. Projects preference directory. Runtime directory. Transient non-essential data like sockets or name pipes. State directory. Okay, so that's under .local state. Okay, so it's something we can use in the future, definitely. Next, let's move on to logging with tracing. What do we have here? Set up logging with tracing. You'll need to install tracing and a few related dependencies. Okay, so let's do this step by step. Let's make use of the same project. That was fast. So tracing. Let's see in cargo. So we have tracing error and tracing. And then let's copy this one. Cargo tracing subscriber. Tracing subscriber. Okay, what's next? So we already have directories. We have caller, iRing. These are optional, but let's just add it in as well. Okay. Lazy static. Lazy static is here. What can we do with this? Let's see. You can paste the following in any module in your project. Tracing project, lazy static. Sorry, I was muted. So how should we do this? So it says you can paste the following in any module in your project. Module. Okay. Function project directory. Get data directory. Initialize logging. Then there's a macro. And then call initialize logging in your main function. What is this? Will it look like this? Additionally, the location of the log files would be decided by your environment variables. Okay, so it will generate logs. Logging, okay, because it's logging. Module is this? Okay, so let's try. How do we create module? Module. New folder. Was it lib? It was lib. Let's check again. There's no harm in checking, because I do forget things also. Rust modules. Modules. Mod my mod. Okay. I need to put it in lib. I already forgot about this. Okay, so let's create a mod. My mod. Okay. Can delete this. Delete. So maybe here. Set. Mod. My logs. Okay. And here, let's comment out these things first. My logs. Do something. AC static. AC static. Let's copy this part. Copy. So why did I copy only this part? Yeah, because we've already tried project DIRs, it's already there. And AC static. This one we can put. Can we put it outside mod? Yeah. And probably in this one we can put inside mod. Rules all the way here. Yeah. So many errors. Let's fix the errors one by one. Project DIRs. Oh, it goes inside the mod. Then we copy all of this. Okay. What about the other errors? Data folder. Cannot find value data folder in this scope. Use create data folder. Okay. Create data folder. Let's fix then log file. Create log file. wrong with this one? Safety. stdenv. Use stdenv. Add unsafe block. Unsafe block. Why do we have to do that? Quick fix. The quick fix was okay. This module contains function to inspect various aspects, such as supplements, current directory, and various other important directories. I'm not sure why we need to use the unsafe block. It seems like the quick fix also resolves some of the errors. So about this log env, consider importing this static use crate log env. Import log env. Where did it go? Log env here. Okay, so what else? My logs. What do we call that one? Initialize logging? Question mark. In your main function. Okay, so this operator can be used in function that returns result or option or another type that implements from residual. Okay, let's try this one. I don't need that anymore. Just do cargo run. It's a warning. So what happened? What happened? Initialize logging. Okay, initialize logging. Get data directory. Okay, get data directory. So you have directory file clone file. What does it do? I have no idea. What does it do? Not file subscriber, tracing subscriber. Okay, and with file, with line number, with writer, with target, with ANSI, with filter. Does it write anything? For key, Rust log. Where does it go? Okay, so there's a Rust log. Data local dir. Okay, so local. Maybe it's in .local share. Local share. Local share. CLI. Oh, there's a log file. Huh. Yeah, there's a log file created here. 2318. Yeah, so just a while ago. Yeah, but it's 0. The log level is decided by your crate name, log level environment variable. Default is log level filter info. Okay, additionally, the location of the log files will be decided by your environment variables. Okay, so it just created the log file where in .local share. Okay, so that is based on what was that? XDG directories. Trace debug, macro rules, trace debug. Similar to std debug macro, but generates tracing events rather than printing to std out. By default, the verbosity level of the generated events is debug, but this can be customized. Trace debug. So how do we use this macro rules? Trace debug target. We need the target. Trace debug. Okay, maybe that's how we can write. That's how we can write some logs into the file. Okay, so let's see. My logs trace how do we use trace debug? Pub. No. Put a pub here. Oh, trace debug. Okay. Let's see. What can we put here? Maybe let's just put some text. This is the first log. And let's run this one. Let's open a new window also, and then we can do a tail minus f. Where was that? Dot local share CLI log. Okay, and let's see. How do I know? Because it's here. And cargo run. Run. Okay, so nothing happened. Quit. Still 0. Why? Tracing events rather than printing to std out by default. Okay, so by default it is debug, but this can be customized. Okay, the log level is decided by crate name log level. By default, crate name log level. Cargo crate name. We have that. Echo cargo crate name. Where is it coming from? env. Maybe let's display this one. env let s equals and debug s. S is CLI arguments. Okay, CLI arguments is this one. Okay, so there's some value. is some value there. Project name, log level, lazy static. Package name. Log file, log env, data folder, project name. Watch ex. I don't know how to write the log. Trace debug. I think I need to learn more about macros. Level, where is level? Okay, level is here. Let's see. Rust macro custom syntax. Maybe let's search for this one. Okay. There's an expression. Okay, so expression. Expression is here. Value. Module path. I have no idea how to use this. Stringify. Okay, stringify. Maybe this one is doing something. But there is nothing here. Event. Event is debug. Rust stringify macro. Okay, so stringify. What does it do? Stringify 1 plus 1. That's okay, it will convert it into a string. Stringify expression. Okay, so I think it will supposed to write something. So it's in default as debug. Okay, so default as debug and Rust log. Where can we find this one? Rust log. So environment, setting the variable. Okay, so Rust log is set. Key Rust log, then the value. And what is all of this? File name, display line number, writer, target, tracing subscriber. Okay, so there's tracing subscriber. Tracing is a framework for instrumenting Rust programs to collect scoped, structured, and async aware. Okay. Layer trait. Modular implementations of specific behaviors. Let's look at some examples. I think we had this in the cargo.toml. That's all. What can we do here? Oh, we saw the log file, not log. Where was it? Here. Yeah, so the log file is here, but it's empty. Although I tried to do a trace debug. Trace debug. Trace debug. Yes. Okay. Okay. Here. And What happened? Why is it expecting something that looks suspicious? It is expecting something. Logger. Maybe let's do something like this. Result. Result report. Only return OK. But how about report? I don't think we need to do that. Ah, that's why there's a question mark. Trying to do here doesn't make sense. We don't need that. I'm stuck. Okay, so I think we need to go back to basics, just like the CLI argument. So we need to dissect how to use tracing. Okay, let's start with tracing. Tracing example. Of course, I will give you something. Tracing subscriber. Okay, so tracing is a framework for instrumenting Rust programs to collect structured event-based diagnostic information. Subscribers. Okay. For example, tracing introduces the concept of spans. Like a log line that represents a moment in time, a span represents a period of time with a beginning and an end. The program begins executing in a context or performing a unit of work. It enters that context span, and when it stops executing in that context, it exits the span. The span in which a thread is currently executing is referred to as that thread's current span. And now you have events. Events are comparable to the log records emitted by unstructured logging code. Unlike a typical log line, an event may occur within the context of a span. Tracing event level, something happened, span. In general, events should be used to represent points in time within a span. A request returned with a given status code and new items are taken from a queue and so on. Something happened inside my span. Okay, so events records an event outside of any span is here. So outside that you have event. Records an event within my span. Something happened. Okay. Usage of tracing, recording spans and events. So tracing, span macro expands to span struct, which is used to record a span. My span enter. Any trace events that occur before the guard is dropped. Use tracing my function. Okay, my function, and this event will be recorded inside a span named my function. Where is span? My function. Okay, my function with the field my arg. Okay, so event is here. Okay, for functions which don't have built-in tracing support, can't have the instrument attribute applied, such as from external create. Span struct has in-scope methods which can be used to easily wrap synchronous code in span. Okay, tracing info span. Span struct has an in-scope method which can be used to easily wrap synchronous code in a span. In scope. Okay, so this is a closure. This is probably synchronous. Events are recorded using event macro. Okay. Using the macro span and event. Span event. Event. Span event. Recording fields. So log level info, answer equals to 42, question life. Field name equals field value. Fields are separated by commas. Okay, so it seems like this is how you can add fields and the value event. Okay. User email, trace, login, user email, user.email plus email. Okay, so these are the different variations in span and events. Span and events. Okay, let's come back to the code and see if we can recognize something. There's no span or event at all. Tracing subscriber. Okay, we're looking at the wrong one. Tracing subscribers. Okay, subscribers. Okay, as spans and events occur, they are recorded or aggregated by implementations of subscriber trait. Okay. Subscribers are notified when an event takes place and when a span is entered or exited. These notifications are represented by the following subscriber trait method. Usage. Oh, just came back to this one. This is another trait. Tracing subscriber. Let's look at the sample source code directly. Tracing subscribers with file. Format Okay, so we have format here. Formats and records tracing events as line-oriented logs. You can create one by calling subscriber. Finish. Finish. Then what is this layer? Configure a custom event formatter. Okay, so it's a okay, this part is formatter. With level, target, thread IDs, thread names. Okay. Okay. Then so it ends here. Then this one is another one. Registry with layer, file subscriber, error layer init. Okay. I think the important part is also here in the macro. Trace debug. You see something different? It looks like this is something different. Maybe let's search for something more easy to understand. Rust logging. Start with this. Rust logging implementation for Rust. Logging in Rust. How to get started. (2023). Okay, so tracing subscriber is also here. Simple example on how it can be used. Log. Log for S. Okay, and tracing is here. Tracing subscriber. Something happened. Okay, so I think I used up most of the time today just going through some documents. So How about in the next video live session, let's try out some of these. I think this one is much more easier to understand, and then we come back to this one again and see how we can relate it to this one. So tracing subscriber, probably under this topic, tracing subscriber. Yeah. Okay, so my apologies, let's end here. So that's how it is doing live. Yeah, so I did not research this in advance, yeah, but because this is live, so I want to go through with it. I mean, this is as real as it gets for somebody who doesn't know that much in Rust. So it's a learning journey. This one is difficult to understand. So that's the plan for the next video. I hope you guys will join me, and see you in the next video. Thank you so much. Bye for now.